Hi, welcome to Unix Academy. In this video, we will do rolling updates and rolling backs with deployments, and we will demonstrate the process of performing them on a deployment in cluster. Rolling updates and rolling backs. One powerful feature of Kubernetes deployments is the ability to perform rolling updates and rolling backs. These allow you to push out new versions without incurring downtime, and they allow you to quickly return to a previous state in order to recover from problems that may arise when deploying changes. Rolling updates provide a way to update a deployment to a new container version by gradually updating replicas so that there is no downtime. Here different types of deployments is available. We are upgrading version 1 to version 2. So first deployment strategy is recreate. The recreate strategy is a deployment. It consists of shutting down version 1 after making sure version 1 is turned off. Then you can start deploying version 2. During this switching from version 1 to version 2, there will be a downtime for the service. This is very easy to set up. There is a downtime version 1 to version 2. So this recreate we won't use normally. Then second one is rolling update. Rolling update is slowly rolled up of version of a app by replacing instances one after the another until all the instances are successfully rolled down. For example, if 10 instances have version 1 which is running behind the load balancer, then update strategy starts with one instance of version 2 is deployed. When version 2 is ready to accept traffic, the instance is added to the pool. Then one instance of version 1 is removed from the pool and shut down. Rolling update is the default upgrade in the Kubernetes strategy if it is easy to use. Then third one is Cannery Deployment. This consists of gradually shifting production traffic from version 1 to version B. For example, there are 10 instances of app version 1 running inside your cluster is the Cannery deployment when you do not want to upgrade all at once. Let's say the instance was 2 instances was upgraded to version 2, then do some testing. If the test results are good, then you upgrade remaining 8 instances to version 2. Once version 2 is ready, then you completely shut down version 1. Basically, this is a ideal deployment method. First, someone who want to test new version before it is deployed 100%. Then fourth one is blue or green upgrading strategy. Using this deployment method, version 2 which is green is deployed alongside version 1 which is blue. It is exactly same amount of instances. After testing new version meets all the requirements, the traffic is fetched from the version 1 to version 2 at the load balancer level. Advantage of this is instance rollout and rollback. Now we will see how to sample deployment. We can use the practice rolling updates and rollbacks. I am giving the descriptor for deployment object. The file name is rolling-deployment.yml. Then I will provide the description here. API version apps equal to apps/v1 for deployment acceptable version, and kind is object deployment metadata rolling-deployment, this name for this deployment object. Spec section I will give the replicas 3 numbers, then selector section match labels nginx, same I am using here also, same as previous video. Then spec section container information, the same thing I am using here also for a rolling update and rollbacks purpose. Then I'm going to save this file, then I will create the file with the kubectl create -f, then rolling deployment YAML script. Deployment was created. Now I am going to perform a rolling update. You can see the deployment previous command nginx 1.7.1 I installed I took the image, and here I am going to change the version of nginx image. For this kubectl set image deployment /rolling _deployment nginx equal to nginx colon 1.7.9 double hyphen record. This double hyphen record flag records information about the updates so that it can be rolled back later. I will run this command, then I will give the kubectl get pods -w command, then here some pods are terminating and some pods are running. kubectl get pods -w will show the what actual work are running on the background. Here we can see the pods rolling deployment. This is our pod. 3 replicas is running. Here you can see nginx image is previous, not this recorded rolling update. Rolling update or 3 terminating and 3 is running. I will explore the rollout history of the deployment with kubectl rollout history deployment /deployment name. We can see the revision 1 and 2. One is none, that is a base version, and the second one is 1.7.9 double hyphen record equal to true. The double hyphen record flag is working with this kubectl command. Then we will change the revision. We can see with one more command the revision also with kubectl rollout history deployment name double hyphen revision equal to 2. It will show the nginx image version 1.7.9 port number and host port environment and other values. Here it's showing labels, also is showing pod template is there, pod template id, annotations, everything it will show the with kubectl rollout history deployment /deployment name double hyphen revision 2. We can roll back to the previous revision like so. Here only I am having 1 and 2 revisions only. In the real time real environment are having number of revisions. For in that case, rollbacks allow us to revert to a previous state. For example, if a rolling update takes something, we can quickly recover by using the rollback. For this purpose, we will use revisions. kubectl command we will use here. The version flag will give more information on specific revision number. We can also roll back to a specific version with kubectl rollout undo is for a rollback deployment slash rolling hyphen deployment double hyphen 2 hyphen revision equal to 1. Here I am having only one revision, no need to provide double hyphen 2 hyphen version equal to 1. I will give just kubectl rollout undo deployment slash deployment name. It was rolled back. We can get the kubectl get pods, list these pods. 3 pods are running without a downtime. We can rolling update we can do, as well as we can roll it back. We can also control how rolling updates are performed by setting max search and max unavailable in deployment spec. I will open this file again. Here I will give the strategy in the spec section. Strategy rolling update colon max search colon 3 max unavailable colon 2. What is max unavailable and max search? Where max unavailable is a spec strategy for rolling update. Max unavailable is an optional field that specifies the maximum number of pods that can be unavailable during the update process. The value can be an absolute number or a percentage of desired pods. I am giving max unavailable 2 here. We can use percentage also. The absolute number is calculated from percentage by rounding down. The value cannot be 0. If it is 0, the default it will not allow 0 value. The default value is in percentage 25%. And max search also is an optional field that specifies the maximum number of pods that can be created over the desired number of pods. The value can be an absolute number or a percentage of desired pods. The value cannot be 0 here also. If max unavailable is 0, normally we did not provide the strategy of max search and max unavailable. Always 0 is there. Max search we can provide with strategy. Here I provided the max search 3. In the Kubernetes cluster, in this percentage was 25% for max search and max unavailable by default. Then I am going to create this file. kubectl, I will give the apply command here, then -f rolling deployment. I edited this file only. For this I will give the apply command. First time it will show the warning, and again you can see the deployment configured here. You can see this with kubectl describe command. I already mentioned kubectl get deployment. Rolling deployment is running successfully. Then I'm going to give kubectl describe deploy deployment name. In this, events also is showing number of events scaled up. This is my deployment description, labels, annotations, then selectors, replicas, strategy type, rolling update, minimum ready seconds. Minimum ready seconds means it is also an optional field that specifies the minimum number of seconds for which a newly created pod should be ready without any of its containers crashing for it is to be considered available. Then rolling update strategy: 2 maximum available and 3 maximum surge. This strategy I provided in this YAML script. Then pod template. This way we will create the will give the max available, unavailable and maximum surge. Okay friends, subscribe my channel for further videos. Thank you.